I've got a log here from ladysman. Ladysman, you reminded me. I missed you, I guess, back on the 26th. I do apologize for that. Didn't do it on purpose. I always try to go back and catch all the ones that I missed since the last time I did it, and I guess one way or another you slipped through the cracks. But better late than never, and let's see what we can do. You posted your setup here, and it says you're using Betaflight V2. And if that's the case, the very first thing I notice is that your D term cut value is too low. I don't know what the under the hood differences are between Betaflight V2 and V1. I know that Boris switched to using an FIR filter or FIR filter, depending on how you say it. I don't actually know. Um, but one of the effects is that the default for D-term cut hertz is way higher. It's like 40. And maybe that's because, or I think it's 30 in PID controller 1. Anyway, it's something like 30 or 40. And maybe that's because the FIR filter is doing such a better job of filtering the gyro that there's less noise, and so you can filter the D-term less. I don't know, but the he did it that way for a reason, and so we should stick with that. The more you filter, the lower your cutoff frequency on a low pass filter, the more delay there is in between the input and the output of the filter. And that means that the D term is less able to respond to things like prop wash oscillation. And so when you describe things like maybe bounce after a flip or shakes on descent, especially shakes on descent, that could all be because the D term is delayed too much relative to the P term. And so where the D term is supposed to be sort of, if you imagine like a bunch of rowers on an old type of rowing vessel ship, they all have to pull at the same time. Or if you imagine a bunch of guys, they're sailors, they're going heave ho on a rope. If they don't all pull at the same time, nothing gets done. If there's two of them and one of them's pulling and the other one is pulling just slightly later, they're going to get a lot less work done than if they both pull at the same time. And so that's kind of a way of describing the way the D term and the P term need to interact. They're not completely, the D term leads the P term, and that's just the way it works. But if the D term has too much delay relative to the P term, they'll get sort of out of sync, if you will, and the D term won't be as effective at doing its job. So your D term cut of 10, with Betaflight V1, that was down in the range, the low range of acceptable. But with Betaflight V2, my hunch is that that is way too low. And the only reason I say that is because Boris has helpfully set the defaults for us, and he set them to like 30 or 40. I would strongly advise you to put this back up. Forget about Betaflight V1. The default has changed, and there's a good reason for it. Put this back up to like whatever the default is in Betaflight V2 for your PID controller. I believe it's different between PID controller 1 and PID controller 2. I vaguely recall when I set it up, that's what I noticed. But put it back at the default and see if your flight gets better. Okay, let's take a look now at your video and look at the specific things that you're seeing. So here's the yaw example you gave at around 20 seconds, and we're just going to watch it real quick, and then we'll talk about it. Okay, let's go back now. So what I'm seeing when you do this is when you yaw, I'm seeing some roll get coupled in. And if we watch slowly, I'm not going to play it forward, but I'll just slide it forward. The first thing I want to do is I just want to check your sticks to see what you're doing, to see if that is potentially causing what I'm seeing. So here goes your yaw gyro. Your yaw is beginning. And notice the pitch you pitch, this is pitch forward, I believe. We can just look. And you roll to the left. By the way, it is really non-intuitive and confusing to me that left yaw is above the axis and left roll is below the axis. I have no idea why that would be. It seems really backwards to me, but seems like left yaw and left roll should go the same direction, but hey, what do I know? Anyway, you can definitely see there's some pitch forward and there is some left roll here. Now, the left roll is at least in part because of the stick here. Especially if you're running camera up tilt, it's going to be very hard to do a perfectly flat roll because it's kind of hard to describe this without having like a little model of a copter to show it to you. You know, like those little model jet airplanes they had in Top Gun. But if you're pitched forward and you do a yaw move, the copter doesn't, it rotates about its existing axis, which is pitched forward, you know, and so you get what appears to be some coupling. The horizon appears to roll to the right if you yaw left and vice versa. And that has to do with maintaining the existing pitch angle. So if you imagine that you're pitched forward 45 degrees and then you yaw left 90 degrees, the end result will be that you're pitched to the right 45 degrees. Or sorry, rolled to the right 45 degrees. So anytime you're not just doing a perfectly flat hover like a camera platform and you're doing a yaw move, there's going to be a lot of coupling. And so it's a little hard to judge whether what we've got here is a tuning issue or just a pilot, training issue. Being able to coordinate a roll or a yaw move by putting in just the right amount of right stick is a matter of training. What I would suggest doing here is a drill I like is to put in some, say you put in some left yaw, the copter starts to yaw, and as it does that, the horizon starts to appear to roll to the right. And now add just enough left roll to flatten the horizon out again. So just hold the yaw stick exactly where it is. Don't move the yaw stick. And add in just enough roll stick to keep the horizon level and just feel for where that is. Do this somewhere in a big field where you're not going to have to worry too much if you're just sort of drifting all over the place. And you obviously you have to maintain altitude as best you can, but hopefully that you've got that kind of down. So yeah, just put in a little bit of left yaw. The copter will start to yaw to the left. Since you are probably pitched forward, because most people fly with some camera up tilt, the horizon will start to appear to roll to the right, and then you add in just enough left roll to counteract that. And that'll kind of teach you to coordinate your turns. Once you get a feel for exactly how much roll you have to put in to keep the horizon flat, you can then choose whether you typically don't want to put in a little more to cause the horizon to roll into the turn. But it may just have an issue of pilot training here. It's a little hard to judge whether it is whether it's a tuning issue. Let's watch it again. And then you've got a little bit of wobbly looseness coming out of it. But again, you're kind of pushing it around with a stick, and it's a little hard for me to judge whether that is tuning or whether that is pilot training. So now let's take a look at the yaw and the roll PIDs and see if there's any insights there. So this is a relatively mild turn, so I'm not sure we're going to see a lot in yaw. We see the P term push into the move. The move begins, the gyro goes up. The I term builds. Now the P term has gone negative. The I term is still pulling you into the move. That's not ideal. You may have a little bit too much I gain. One thing you can look at is when the P term changes signs right here, how long does it take the I term to catch up? And if it takes too long, you may have too much I gain. Alternatively, you may not have enough P gain. So another approach here would be to raise P gain. And my experience has been that you can have P gain on the yaw axis pretty high before you start to get problems because yaw authority on these copters is relatively weak. Now P is close to the zero axis and I is close to the zero axis. That's good. They're in agreement that we're moving at about the right rate. And now we're ending the move. P goes negative to end the move, and I goes negative as well. Nothing to say there. As far as roll, it certainly looks like on the roll axis, the P is close to 0 pretty much the entire move, and I is close to 0 pretty much the entire move. And what that tells us is that the copter is doing almost exactly what it's commanded to do. So we don't see the P term pushing you into or pulling you out of the move. We don't see the I term accruing a lot of error. So my gut feel would be that what's happening here is a matter of pilot training. As the move ends, what happens as the move? Here's the move ending, and we've got this wobble, as it ends. You actually some pitch here as well, some destabilization there. Again, roll is very close to the 0 axis. That tells me that there's probably not, the PID loop thinks that everything is right. We don't see the P term doing anything. That means that error is low. So at least on the roll axis, I don't think what we've got here is a tuning issue. If we look at pitch, pitch should be pretty, you didn't really do a lot with pitch here. It looks like you're actually pulling back on the stick just a little bit. I'm not sure if that's intentional. You may want to work on sharpening up these moves in terms of being able to isolate the sticks from each other. In other words, you're rolling to the left here, but you're also pulling back just slightly, and you may not mean to do that. I mean, I'm not sure whether you do or don't. If that's not intentional, then you can really practice keeping those isolated, except when you intend to do them both at the same time. And again, here we've got pitch forward and now pitch backward. But not that much. Yeah, so I'm not sure that this looks to me like a tuning issue. I know that's not the answer that you probably wanted to hear, but I don't see the PID algorithm doing anything that looks to me like it's bad behavior and that needs to be fixed. So my guess is that this is something that's happening between the the fingers and the sticks, and not something that's happening between the flight controller and the motors. Here we've got a roll with some bounce at the end. Let's watch that. So it's very clear here that this is P term oscillation, right? I mean, that's just exactly what it looks like. At the sharp end of the move, we got the P term jiggling back and forth. It goes on for quite a while, and you can see that it is showing up in the gyro in the camera. It goes on from about 06.4 to about 07.2, so roughly 0.8 of a second. That's certainly a substantial amount of time and definitely very noticeable and worthy of trying to tune out. If you've raised your D gain and that hasn't fixed it, the next thing to do is to lower your P gain. Those are really the two things I would suggest. And if we look here, your D is 0.47 on pitch and 0.29 on roll. You could probably afford a little more D on roll. If that doesn't do it, then you start lowering your roll P gain and see if that fixes it. The other thing is that this may be a hardware issue depending on what kind of ESCs you're flying. Well, they're RG20s. Never mind. Those are great ESCs. That's not the problem. Yeah, so I would tweak your P gains on roll or your D gains depending on which helps solve it. But you really ought to be able to tune this out. This should be completely fixable. So I wouldn't worry too much. Anyway, I hope that was helpful. And again, I do apologize for missing your post from so long ago. Thanks very much for submitting your video. Hope it was helpful, and happy flying.